Welcome to the next major chapter of our CCNA journey, network access. This domain makes up 20% of your exam and is where we move from theory into the actual configuration of a business network. Objective 2.1. Configuring and verifying VLANs. Think of a VLAN or virtual local area network as a way to take one physical switch and slice it into multiple smaller virtual switches. This keeps your network organized and secure. 2.1a. Access ports for data and voice. An access port is a port on a switch that connects to a single end device, like a computer. These are known as data VLANs. However, in a modern office, you often have an IP phone on the desk. To save on wiring, the phone plugs into the switch, and the computer plugs into the phone. The switch uses a voice VLAN to keep that phone traffic separate and prioritized so your calls don't drop when someone starts a large download on their computer. 2.1b. The default VLAN. When you take a Cisco switch out of the box, every single port belongs to VLAN 1. This is known as the default VLAN. While it makes things work instantly, it's a security risk. Professional engineers always move their devices into custom VLANs, like VLAN 10 for accounting or VLAN 20 for sales, to keep traffic isolated. 2.1c. Inter-VLAN connectivity. By design, devices in different VLANs cannot talk to each other. It's like they are on different islands. To bridge that gap, we need a referee to move data between them. This is called inter-VLAN connectivity. We usually achieve this using a router in a setup called router on a stick, or by using a high-end layer 3 switch. Objective 2.2. Inter-switch connectivity. When your network grows and you have multiple switches, you need a way to carry all those different VLANs between them using a single cable. 2.2a. Trunk ports, 802.1q, and the native VLAN. If an access port is a single-lane road, a trunk port is a massive multi-lane highway. To keep the traffic organized, we use a protocol called 802.1 quetzales. It tags every piece of data with a VLAN ID number so the switch on the other end knows exactly where it belongs. The native VLAN is a special lane on that highway meant for traffic that doesn't have a tag. For everything to work correctly, both switches must agree on which VLAN is the native one, or you'll run into connectivity errors. Objective 2.3. Layer 2 discovery protocols. When you sit down at a console, you often need to know what is physically plugged into the other end of a cable without walking to the server room. CDP and LLDP. CDP, or Cisco Discovery Protocol, is a Cisco-only tool. It allows Cisco devices to introduce themselves to each other, sharing their names and versions. LLDP is the industry standard version. It does the exact same thing but works across different brands, like connecting a Cisco switch to a third-party server or a VoIP phone. Both are essential for mapping out a network you've never seen before. Objective 2.4. Ether channel and LACP. Sometimes one single cable between two switches isn't enough speed, or you're worried the cable might fail. Layer 2 and Layer 3 Ether channel allows you to bundle up to 8 physical cables into one single logical link. This gives you way more bandwidth and instant backup if one cable breaks. LACP, or Link Aggregation Control Protocol, is the standard way switches negotiate this bundle. A Layer 2 Ether channel simply acts like a giant switch port. A Layer 3 Ether channel acts like a high-speed routed link between two routers. It's all about creating a faster, more reliable backbone for your network. Final study note. As you record this, remember that network access is all about control. You are controlling where traffic goes with VLANs, how it travels with trunks, how you see it with discovery protocols, and how you speed it up with Ether channel. Mastering these 4 topics means you've mastered the core of the local area network. Now, everything we've talked about today, VLANs, trunks, and Ether channels, can feel a bit abstract until you actually type the commands yourself. I highly recommend that you don't just watch these videos, but actually open up Cisco Packet Tracer and build these topologies. Try creating 2 different VLANs, assigning ports to them, and then setting up a trunk link between 2 switches. If you can get a computer on one switch to talk to a computer on another switch across a trunk, you've truly mastered the fundamentals of network access. I want to hear from you. If you'd like me to create a dedicated, Step-by-step video specifically using Cisco Packet Tracer to show you exactly how to configure everything we covered today. Please leave a comment saying, Cisco Packet Tracer video. Your feedback helps me decide which labs to build next. This next section is the heart of a stable, secure network. We're moving from basic connectivity into the safety nets and management tools that professional engineers use every day. Objective 2.5. Rapid PVST plus Spanning Tree Protocol. The Spanning Tree Protocol, or STP, is the network's insurance policy. It stops broadcast storms, where data circles switches endlessly until the entire network crashes. Rapid PVST Plus is Cisco's enhanced version that handles these loops much faster, allowing your network to recover in just a few seconds if a cable fails. 2.5a. Root bridge and port names in every spanning tree network. One switch is elected as the boss, known as the root bridge. All other switches find the fastest path to it. You can manually set a primary and secondary root bridge to make sure your most powerful switches are always in control. The root port is the best path on a non-root switch to get to the boss. A designated port is a port allowed to forward traffic away from the root. An alternate port is a backup port that is currently blocked to prevent a loop. 2.5b. Port states and roles with Rapid STP. Ports move through three main states: discarding, not sending data; learning, building the MAC table; and forwarding, passing traffic. 2.5c and 2.5d. Stability and security features. PortFast. We use this on ports connected to PCs or printers. It tells the port to skip the learning phase and go straight to forwarding, so the user gets a connection immediately. BPDU Guard. This is a safety lock. If someone plugs a rogue switch into a PortFast port, BPDU Guard will immediately shut that port down to protect the network. Root Guard and Loop Guard. These ensure that no other switch can steal the root bridge title and that a broken cable doesn't accidentally create a new loop. BPDU Filter. This stops a port from sending or receiving STP messages entirely. Use this with caution. Objective 2.6 and 2.7. Wireless Architecture and Connectivity. 2.6. Cisco Wireless Architecture and AP Modes. Wireless in a business isn't just a router. We use APs or access points and WLCS or Wireless LAN Controllers. Local Mode. This is the default. The AP handles user traffic and stays in constant contact with the controller. Flex Connect. This is designed for branch offices. If the connection to the main office controller drops, the AP can still keep the local Wi-Fi running. 2.7. Physical infrastructure connections. To make wireless work, the hardware needs to be plugged in correctly. APs usually connect via an access port. WLCS use trunk ports to handle multiple wireless networks at once. LAG link aggregation. We often bundle multiple cables together for the controller to handle thousands of users without slowing down. Objective 2.8. Network Device Management Access. Once the network is running, you need to log in to manage it. Insecure methods. You should avoid Telnet and HTTP because they send your passwords in plain text. Anyone listening on the wire can see them. Secure methods. Always use SSH and HTTPS. These encrypt everything so your credentials stay safe. Console. This is your physical emergency connection using a cable plugged directly into the device's console port. Authentication to CAX Plus and Radius instead of every switch having a different password. These protocols let you use one central server to manage who can log in. Cloud managed. Tools like Cisco Meraki allow you to manage your entire network from a web browser over the internet. Objective 2.9. Wireless LAN GUI configuration. When you log into the WLC web interface to set up a new Wi-Fi network, there are four main areas to look at. WLAN creation. This is where you name the network and give it an SSID. Security settings. This is where you choose your encryption, like WPA2 or WPA3, and set the password. QoS profiles. Quality of service. This ensures that a voice call or a video meeting gets priority over someone just browsing the web. Advanced settings. This covers things like fast transition, which helps your phone stay connected as you walk from one end of the building to the other.